Well, today I will try to explain a little bit what we have done and how we came to the conclusion of the operativity of the pilot plan installed in Rincon de Leon wastewater treatment plant in order to valorize brines and produce well several things. Water in one case, but one important um, asset in the cleaning and also in the disinfection section, which is the hypochlorite. Just to give you a brief introduction, well, basically we are going to be focused in the water line of the wastewater treatment plant, explained very detailedly by Ignacio previously. And what we are going to install is a treatment train that I will explain later, but it contains a couple of things that one need to take into consideration, which is the use of novel selective electrodialysis membrane application. And then on the other side is that we are going to explain the operation and results that we have been obtaining. At the end of the day, well, this presentation contains an overview of what has been done related to this task 2.1.3 and all the energy requirements, the PNID, the capacity, the different operation condition. Um, we're going to see it together. Just to give a kind of context, besides we had a very nice explanation previously. Well, the wastewater treatment plant in Rincón de León has two lines, the A and B. There is a kind of 50% capacity in the case of B as compared to the A. A is the principal one that fits the tertiary treatment or the regeneration facility. And the main difference is that the conductivity in the line A rounds about 2,500 microsiemens per centimeter, and in the case of B is a little bit larger. It doesn't mean that the line B is not used in the regeneration. It could be done for regeneration purposes too, but the main line is the A line, and it, well, as you can see, what is just a conventional treatment of waste removal, primary clarification, biological treatment, and a secondary clarification. Well, but it's important to have the context of what is happening currently. About 47,000 cubic meters per day are being treated in the wastewater treatment plant of Rincon de Leon. From that, about the 30% is regenerated, and an important about 1,800 cubic meters per day are sent to a submarine emissary as a brine. Despite the fact that we are recovering water for several purposes, such as agriculture, street cleaning, or irrigation. But this is also an opportunity. So this brine, as you know, may have some potential benefits because it contains salts that could be interesting if transformed in a proper way. So in this scenario is where B-WaterSmart came up and with a proposal of regenerating the RO brine that is disposed currently and transformed into water in one side and sodium hypochlorite on the other. And it is just a treatment train in which selective electrodialysis is placed in integration with a softening and electrochlorination step. So basically, this is quite simple. Things are going to get complicated. But basically, the electrodialysis that we are using here, in order to be operative, we need to deal with the concentration polarization on one side, but in the other, the scaling or precipitation of salts of divalent ions that are present in these real waters that came from the reverse osmosis. But then there is the option of trying to not withdraw the multivalent cations, maintain the conductivities high, and try to not modify a lot the conditions of the D-valence in order to not precipitate, as in the case of the conventional and regular electrodialysis. So these selective, monovalent selective membranes allow us to concentrate the, the monovalent solutions, such as chloride. Is interesting for the sodium hypochlorite production and the sodium. Well, basically the the structure of the unit is quite conventional. It's just two regeneration tanks. We have the opportunity to to be fed with RO water in order to control conductivities, and this is going to be a crucial step in the operation of the B-WaterSmart concept, as we will see later. But at the end of the day, we are going to concentrate to a certain conductivity, a set point of conductivity. Um, the water that are going to be sent to the softener, and then ultimately to the electrolyzer. And at the end of the day, applying energy and chemicals, obtaining this transformation that is really interesting. So the electrolysis stack is relatively large. So this is how it looks like. And this is the facility that we have installed in Rincón de León. And well, it has a capacity of treating about 800 cubic meters per hour. Well, the next step is the softening. Again, is a kind of a regular step with the ion exchange column multimedia, which needs bases and acids to be regenerated once it reaches to saturation stage. It is connected to a buffer tank that contains the water that is concentrated in the previous unit in the electrodialysis, and then, of course, then it is sent to the electrolyzer. In the electrolyzer, again, a buffer tank that contains, and it is just a single pass that we are producing, about 140 liters per hour of sodium hypochlorite of about 4,000 ppms of free chlorine. And this is what we have installed, how it looks like in general. This is the electrodialysis unit, the softening unit, the electrochlorinator, and this is how it looks like in reality when you will see everything in place in the demo site. So, talking about what we have done, basically we started with a conventional batch process in order to optimize the sodium chloride transfer from the brine that comes from the reverse osmosis, and a synthetic brine that will be concentrated due to the transfer of these ions that will be used for ultimately produce the sodium hypochlorite. We have tested different conditions of voltage and time. One of the important things was that we had a set point of the synthetic brine that we wanted to produce, and we wanted to produce a certain volume in which by maintaining the conductivity, either by moving ions or by adding water, we are capable to produce a volume of this brine that will be used. Of course, at different conditions, we have a different mass of sodium chloride that was transferred to the concentrated site, and with an energetic cost, of course, per kilogram of sodium chloride that was used. And then this was important because at the end of the day, we need to see the overview of the whole process that we will see at the very end of the presentation. So I was highlighting two specific cases. One trial that was done at 30 volts, which is quite important to have a look in the conventional batch process. You will have one side with the feed solution that is initially at high concentration, and it ends up at a lower concentration, and a concentrated side that increases in concentration. This is important because we will need a time in which we will need to spend some energy in order to fulfill this set objective, and of course during this operation, there is no water that is being produced because it is not at the current set point that we will need to do. So we will need to start over and then produce more water. And this is a way to produce in batches. But then we realized that doing a second batch just next to the other with different conditions too, that if we try to maintain the conductivity, we will be able to overflow this water and to produce the concentrated brine that will be used to produce in the electrolyzer the sodium hypochlorite. And it also has some consequences at the level of the energy requirement because it reduces the electrical resistivity of the system. And well, what you can see is that yes, we have a reduction in the initial brine that comes from the RO, and then we are also concentrating the final synthetic brine. At the same time, there are no relatively movement of the calcium or magnesium, which are salts that precipitate and create problems. But in general, and this is the overall characterization of these two trials that I am explaining now. And as you can see, well, there are some ions that are transferred, others that are not, more than better. And there are some selectivity towards monovalent as expected because of the membranes that I was explaining at the beginning. And basically what is important from here is that once we have this characterization and we have decided that this is correct and the way that we are going to operate is in this case, this feed and bleed application, we can then pass later to the softener and electrochlorination unit. This is a synthetic solution that contains nothing but sodium, well, conventional industrial sodium chloride that contains not much of the calcium and magnesium, but in order to be sure that nothing will happen, what we wanted to assure is the transformation of this sodium chloride towards the sodium hypochlorite. And you can see a reduction of the 30% in the chloride due to the single pass in the electrochloride, and it's about this 30% of the sodium chloride was transformed. And not much movement of other ions present in the solution, which was really important. So if we look into overall system efficiency, I have highlighted a couple of points. This is the calcium and magnesium that is passing through towards, well, this is the inlet RO brine that we are using from the wastewater treatment facility, the regeneration unit, I mean the tertiary treatment. Then the final synthetic brine that was concentrated due to the electrodialysis, and then ultimately the softener produced. So we can see that it has, yes, a concentration in the electrodialysis side for the calcium, a slight reduction in the magnesium, but then after the softener, there is a 1 order of magnitude reduction in the concentration of this hardness. But in the case of fluorides, after the softener, we wish to maintain the concentration in the concentration stream, but there is a loss of about 10% to 20 in the worst case scenarios, 20% of reduction of the chloride that is present. It needs to be taken into account because at the end of the day, as you will see, we need to produce a kind of KPIs that will help us to see how the process is going on. And at the end of the day, we can take into consideration the production of 1 kilogram of free available chlorine through the whole system, but it needs to account that you will need a certain volume of initial RO brine, the expenses of chemicals, some water from RO to produce the clean concentrated brine, and due to the regeneration of the softener, there are going to be production of some other brine that needs to be also taken to the MSI. At the end of the day, the cost of operative B-water treatment system is about 1.7 euros per kilogram of free available chlorine, which is really, really interesting because we are transforming this problem into a beneficial. This is the last slide that I want to present. At the end of the day, we have demonstrated the continuous operation of this facility. The maximum flow in overall, it was about 90 liters per hour, taking into account the production of the electrolysis, but due to the use of the usage of the buffer tanks, at the end of the day, we can produce also at 140 liters per hour of a solution, about 3,500 ppm of free available chlorine after the chlorination unit. So this is everything from my side, and thank you for your attention.